Hey, this is Steven from Legit Tech Tutorials and the Green Engineers. Welcome back to my tutorial series on the Shredder, the product development series of the Shredder. So basically what I want to talk about today, I took a couple days off here because I didn't have a chance to go get some samples for what motor I'm going to use. I went and got some today, and I've been busy cleaning out the garage, getting ready for the next step of getting these shredders, which should be coming here anytime. I mean, obviously we had a holiday here in the United States on Monday, so the shipping companies were probably not shipping on Monday, so it might take a little bit longer than normal to get it. So they probably shipped at UPS 5 days. I did not ask for a tracking number, so I don't have anything like that. I probably should have done that, but I didn't. So let's go ahead and talk about what I have here today to look at. Sorry about that, I had to open up the door so my cat could get out if she wants. So basically what I did is I went and got a motor, and then I found the torque, the impact wrench. And I also happened to see something else that I also liked. So let's go over that as well. Okay, so come here. Okay, so basically what I found is, again, we're looking for something that has about 30 RPM and as much torque as possible. So I happened to find something. This one looks, oh, this is the lower. So I happened to see this one, which is a Chicago Electric, which is Harbor Freight's electric drill motor brand. And it is a 1/2 inch heavy-duty spade handle drill. Now, if you look at this guy has about the same amount of power as that torque wrench, 7.5 amps at 120 volts. So 120 times 7.5 is 900 watts. And then divided by 750 is about 1.25 or 1.2 horsepower. Now the most interesting part of that about this one is that it has a 500. It says on the label 600, so I'm not exactly sure. I might have to buy one of those tacks to read its no load speed. But it's saying on the label 0 to 600 RPM. So that's way better than the 2100 RPM. I do also have the torque wrench. I bought both of them. And if you remember, the torque wrench is a 7 amp at 120, and it is rated at 2100 RPM and 230 foot-pounds of torque maximum. But obviously the 2100 is way too high, and I do plan on gearing this. But the best thing that I like about this drill motor is, you see, it has a handle. So now the interesting thing about the handle is that it has these tapped holes inside of the housing that allows for something to screw in there. In this case, is the handle. It's a 3-position handle, so you can screw it on this side, or this side. There's nothing on the bottom, and then it has this handle on the back. Now this piece here is plastic, but it actually has a threaded part on the back that this guy will actually thread in there, and that's what basically threads his handle on, so you could actually spin the handle around. Now obviously I have no interest in the handles itself, and also it's just like a standard, that's weird, it has a completely different color handle. It must have been a prototype. And also has a completely different back shape, so that must have been some sort of prototype. and the handle, and also this handle is black. So it has a chuck on it. Obviously, I don't give two craps about the chuck. Maybe for prototyping it might work, but it just looks like a regular style thread-on chuck, which I've never actually removed a chuck, so that's going to be interesting to find out. And it is reversible, and it is variable speed. And it seems that the variable speed works very, very well. So, and you can see it does have a handle, so maybe mount sideways or something, starting out, and then obviously what I would like to do is I would like to have this guy as a switch type and have this variable speed as a potentiometer instead of a handle. So you just turn this potentiometer to do the speed. Now what it seems like is at low power it doesn't have a lot of torque, because probably what it's doing is it's switching it on and off very quickly. It's not using a timing based like a brushless motor, as this is a brushed motor, and it does come with extra brushes. So if you do need to take it apart and put new brushes in it, you can do that to extend the life of the motor, which is nice. And also because it's brushed, it keeps the price down, as these shredders are not going to probably see that much crazy amount of use that you shouldn't go through 2 loads of brushes on this thing. Especially that we are going to gear it down further another, 20 times. Because basically my target RPM is 30. So what that means is, because we have 2 blades, we're going to have 2 cuts, 2 times the cut per 30 RPM. So that's a total of 60 cuts per minute. So that's 1 cut per second, basically. Which I think that's plenty fine, that or lower. I don't think you need to go any faster than that. And that's plenty of the torque. And it does seem like it's a very torquey motor, except for that variable speed. So what I would like to do is get rid of the variable speed and just switch it all on or all off, and then be able to do the reverse, right? Because the variable speed, what it does is it just has a, changes a PWM frequency to change the speed. But what that does is it drives down the torque of the motor. So at low speeds, it doesn't have the torque that it should, compared to like a brushless motor, where a brushless motor doesn't work that way, because a brushless motor, it has magnets, while this just has a commutator, right? So basically the only way to control these brushed DC motors is not through the magnets, it's through timing. With like a stepper motor or a brushless DC motor, it could also do it through timing, but it does it through controlling the magnets that move the armature around. So yeah. So yeah, you can see here these guys here. So I have this guy here on the floor. It's very, very nice build quality, and these holes that are tapped in it for the handles are very, very large. So I don't think we're gonna have any issues with mounting this thing. That's why I kind of decided on this one, probably more so than the torque wrench. I do have the torque wrench, and I have the receipt, so I have up to 90 days to return anyways, and both are $115.78 total. So this guy was $55. It says heavy duty, low speed. It says VSR. Variable speed resistor, I'm guessing. VSR drive, I don't know what that means. VSR. But yeah, anyways, ball bearing spindle mount, variable speed, reversible. Oh, VSR, variable speed, reversible. Okay. Yeah. So, let's go ahead and take some measurements on this. Let me kick Tiger off here. Oh. She got attacked by the cord. So let's go ahead and bring my backpack out here, because I have my my calipers in my quad bag here for our RC stuff. Let's go ahead and break that out. Okay, here it is. And let's put it back. Okay, good. Alright, so here it is. Really nice. It's got a nice trigger. It's got a very nice control. It's way better trigger than the than the torque wrench. So that's one thing I gotta give it. Okay, so now these holes, and we have Fusion open in the background, so we can go there if need be. But these holes are 483. So obviously that 483, what is that, 5/16? Either that, or we could look at the handle. Because it's always better to look at the OD, because the OD is what actual size you need, and then you dump down the bolt, and then you use the die to cut down the bolt. 538. Okay. Let's look at bolt sizes. Okay. Yeah, 538, 539. Interesting. Let's look at metric. .539. So it does not look like something there. Let's look at okay, so what about this hole? Okay, so let's look at this hole. See if we go from either side to figure this out. .470. Okay, so 10,000s, well, 14,000s, maybe 9/16 by 12. There we go. Okay, so let's look at the minor diameter, see what we can get in there. 0.467. Well, it should be the same as the hole. Yeah, so I think it's a 9/16 something. Point. It's definitely a coarse thread. but the outside is a 0.539, so it's very strange. I'll have to try my die downstairs. But let's go ahead and size this up in CAD. We're at 15 minutes, so let's go ahead and size this up in CAD. Motor. So this is the, let's go ahead and save this. What are we going to call this guy? This is Chicago Electric 1/2 inch. Okay, so, and obviously I don't know how much room this makes up inside with this chuck here, this chuck on it. So I do have my tape measure and I have my calipers, so let's go ahead and take some dimensions here. So let's take the width here. Actually, we're gonna do top, we'll do top down. So width here is about 3.525. I'm gonna say 3.530. 3.530. Okay. Now the length, that's going to be a little bit harder to do. I'm going to say, obviously I don't know how tall the thread is, but it looks to be about 10 inches. Oops. Double check this guy. Yeah, 3.530. 3.530. Okay, now, how tall is it? Not including the handle. So let's stop right there at the handle. 3.750. And there you go. Obviously, it's got more of a taper to it. Probably this is something to use on a, I wonder if I could talk to them and get a 3D model for it. An outside 3D model, scaled correctly and all that kind of jazz. I would also like to take it apart. And at some point, I'm not going to be able to take the front apart until I take off the chuck. And I would actually like to drill with it, just to get a test of its power. But I'm definitely not, what's the word I'm looking for? I'm definitely not questioning the power this thing has. This thing, I think it was 5 3/4 pounds. So let's see what it says here with this guy. That's definitely more than 5 3/4 pounds. So yeah, the whole thing itself is 5 3/4 pounds, not including the cable. And it does have a chuck and a hole to put the chuck in there, which is nice. So maybe we'll, what I might do right now is I might put it on the floor, and we'll take some pictures, and we'll use that to do some sort of, we'll post them on here, and then we'll do we'll project them and scan it. I mean, basically, kind of copy it. I like it when they put these little chuck holders. It's kind of cool. Anyways, so yeah, let's put it on the floor and see if we can do take some pictures with my phone in some good lighting, as straight as we could get it, and then I'll send it to my Dropbox and we will basically scan it in. Oh, well, just so happens that my phone is dead. Okay. So what we can do is we can kind of that was unfortunate that my phone is dead. We'll have to do it tomorrow. So basically what we're gonna do is today we're gonna do this video that's gonna explain what I have, and we have torque wrench, but we're gonna look at this guy first, and then we're gonna look at we're basically gonna weigh our options because they're both about the same cost. This one's about $6 more expensive. It already is scaled down by about 3.5 times, so it's already got about 3.5 time reduction on it compared to the other one. So it's going to be easier to gear down to 30, which is about 20 times, right? So maybe we'll look at that and we'll see how that looks, because right now I can measure it to figure out what is the distance between the side to the center line, and we could figure out from there basically what we could do as far as the gearing. Alright, so I'm going to say it's about 1.5 inches. I mean, basically it's... Woo! It's basically between these two. Oh, I'm looking at the holes. The holes are incredibly square with respect to each other. So 1.353, 3.453. 3.453. 3.453. 3 divided by 2. So we got about 1.7265 plus. We're obviously going to use that left side to mount. So we could push it over as far as we need be. Because we have one mount on the left, one mount on the top, one mount on the right, and one mount in the rear. And obviously we want the front to stick forward. So let's see. So maybe we could step this up to, in actuality, 2 inches over from the side of the machine itself, and give a 1/4 inch to stick a piece of metal there, and then have some sort of countersunk screw go in there and then go into that hole there. So let's go ahead and look at the general layout of the machine. This guy here. And what is the distance from here to the back? So that's 7.6. So let's see. I mean, maybe we could remove that top portion. I mean, I don't want it to stick too much further past the back. In this case, it's going to be like 2 2.25 inches, 2 3/4 it looks like. Well, I have my shredder here, so let's size it up here. I mean, that's a big motor, no joke. So yeah, it's gonna stick out about 2.25 inches. Not much. And that's with the back cap. That's with the back cap being there. And another thing that I really like about this compared to other options is it has a built-in fan, right, that runs off of the motor on the inside. So technically this should have ways longer sustained run times than some of the other motors, right? And then obviously this here is, I'm pretty sure, metal. Where's that little spinny thing that I have? It was here a second ago. It's got all the magnets in it. It's got a magnet in it. Where did I put it? Oh, here it is. Yep. It's definitely magnetic, so this is probably cast aluminum. So if that's the case and we bolt that to steel, it should easily dump most of the heat into this frame. So we should have a good fan here, and it's got scoops on the side so that it could suck in air. We are bolting directly into aluminum, and in the back it looks like steel thread, so we're bolting right into steel thread. So it does look a little long. Maybe we could pull the back cap off, or maybe even the front cap off, but that you're not really going to gain much. So I think that it's pretty good for its size. I think it could be. I think it could be a little shorter. I think that would probably be the best, as it would be pretty much the exact same size as the shredder itself. But yeah. So I'm thinking this is going to be our answer here, and then what we'll do is we'll also look and see if they have any of this stuff in China and under bulk for bulk. See if we drop the price a little bit, but I'm thinking this is probably the answer over that impact wrench. I mean, that impact wrench is big and it's a little heavier. But let's see. Let's pull it out. Let's take a look. Don't get me wrong, this boy's big, but it doesn't really have any mounting options, right? And there's no variability, it's just all on, all off. But if you look inside, it's got a giant motor in there. And it's really heavy, and it's got really probably big bearings in there. So let's take a look at the length here. So yeah, this one is about to the end of the square chuck, it's about 12 inches. So the other one's about 10 inches, this is about 12 inches. So it's a little bigger. Also has a fan, way higher rev speed, 2100 RPM, only 7 amp at 120. So a little bit less power. It's 840. The other one's 60 watts more. The casing does not look as good. There's a lot of stress points actually in the casing. It's kind of weird. It might have been a bad injection mold pull on this one. But this has got a giant motor in the back. You could just see in through the back how big a motor this thing has. But what that means is that we're going to have to step it from 2100 down to 20. So obviously 2100, or 30, sorry. 2100 divided by 30 is 70 times. So basically what that means is that we're going to a 3-inch diameter. So if we do 2, we have to do a basically they have to multiply up to 70, right? As far as teeth reduction. So 1 could be 35 and then 2, or etc. So I mean, we could go further into the drawing on how that would work. But yeah, I don't know. We're going to have to test the torque numbers on these. Obviously, I would prefer the drill motor because of the mounting options. If we look at the torque, I mean so basically this is just using the generic Chicago Electric impact wrench. So you see here, this is for the brushes, so you can't go in there. But that's what I like. It's very easy to put brushes. And these guys are very, very small screws. Other than that, I mean, the only other mounting point is the trigger. So the only other thing that I'm thinking that you could do is you could grab around this cylinder right here towards the front, and the cylinder is a beefy guy, and it's relatively round. As you can see, it has that slight step, that's basically what it looks like in real life. And it's about 2.36. And the other way is 2.39. So it's about a 30,000th step there. Change in diameter. 2.382. Yeah, it's about 30 thousandths. It's about a 30,000th step. So about 15 each side. So relatively round, so we could have some sort of clamp or something that goes around there. But obviously that's assuming that it's not gonna twist on you. Not really the ideal situation. And then obviously, hopefully that's assuming that this is indeed metal. Get my magnet here. Yep, it's metal. So you should get pretty good conduction around that if we put a piece of aluminum there that grabs onto it. And it'll probably be easier to make than this other one. So basically a clamp that goes around this guy and holds on to it. And maybe we could use that change in diameter to our advantage. Again, this is going to have to be towards the front, and again, this is really heavy, so it's not going to be that balanced. While on the drill motor, it's pretty close to the center of balance, but this has got a big motor on it. An extremely big motor. So maybe I should take these both apart and look into them and kind of make my decision from there. So we will look into these guys tomorrow and see what we can find out. Alright guys, this has been Steven from Legit Tech Tutorials and the Green Engineers. I'd like to thank you guys so much for watching. If you like this video, please subscribe for more videos, and I will see you guys tomorrow. I'm going to have a video in the morning and a video in the afternoon. I have to make up. Now with this video tomorrow, there's still going to be a video, so I need to make up for Monday and Friday. Monday this week, which was holiday, but I'll make up for it anyways, and last week on Friday. So I'll shoot 2 tomorrow, one in the afternoon, one at night, one I'm supposed to, and 1 in the morning, and then I'll do that same thing on Thursday, and then we'll be all caught up. And probably at that point we will be done with designing for the motor, and we will have decided, and by then hopefully we have the shredder and all my tools from Harbor Freight that I need, and we will go from there. Alright, thank you guys for watching. This has been Steven from Legit Tech Tutorials and the Green Engineers. I'll see you guys next video. Take it easy. Peace.